Hi, I'm Bridget Huffman, and today I was talking about the introduction to triangle similarity. So first, I'm going to do my first example, just drawing two triangles and labeling the first one A, B, C, and the second smaller one X, Y, C. Now I'm going to add the length of 10, 16, 14, 8, 7, and 5. Now what you might notice about these triangles is that all of their angles are the same. All their angles are congruent. Now, but are these triangles congruent? No, they are not. But these triangles are what we call similar. We can tell these triangles are similar because if we take 5 to 10, 7 to 14, and 8 to 16, we can see that if we multiply by 2, we can get the number. So if we multiply 5 by 2, we'll get 10. If we multiply 7 by 2, we'll get 14. If we multiply 8 by 2, we'll get 16. So that's how we know these triangles are similar. The way that we can write that these triangles are similar, by simple writing triangle A, B, C is similar to triangle X, Y, Z. Now we want to think of similar triangles as just a blown up or scaled version. And just because they are similar doesn't mean that they're necessarily congruent. But any triangles that are congruent are similar, since the scale proportion will just be 1. But here in this example, we can see that it is 2. So, if you want to write that down, proportion equals 2. Now, to show this in a more mathematical way, we can write x, y, segment xy equals 1/2 times segment AB. This is because xy is half the length of AB. So we can flip this proportion around. It can either be 2 or 1/2. X C segment XC is equal to 1/2 times segment AC. If you look up here, you can tell AC is double XC. And for our last side, we'll be writing YZ, segment YZ is equal to 1/2 times BC. We can check 7 is half of 14. So for similar triangles, we know now that if they are congruent, which these triangles are not congruent, they are just similar. But if triangles are congruent, for example, if they look like this, we know that both of these triangles are similar as well as congruent. But it cannot always flip this other way around. For example, just because these are congruent and similar doesn't mean that these are congruent and similar. These top ones are just similar. We want to make sure that we're not getting confused. Okay. So triangles that are similar have corresponding angles that are congruent. So all of their angles are congruent, but their sides are not. So how we could write this for this example would be angle A, B, C is congruent to angle X, Y, Z. We can check that up here. A, B, C, X, Y, Z. And now just start the rest. Angle B, A, C is congruent to angle Y, X, Z, and angle A, C, B is congruent to angle X, Z, Y. So now that we know that all the angles are congruent but the sides are not, this also goes for congruent triangles, since all congruent triangles are similar, but not all similar triangles are congruent. We want to make sure for our similar triangles that they are all scaled by the same proportion. So we can't just check 2 and say, oh, well, they're similar, like I checked 2. No, we have to make sure all 3 are scaled by the same proportion. Say if this 5 became a 6, these would not be similar. But if it was a 5, then they would be similar. So we should make sure that we're checking all of our sides. And thank you.